Hi guys, Mohit here. And in the last few videos, we learned why Torch compile is so important for LLM inference and how PyTorch compiles regular Python code. But that raises an obvious question. LLMs are just regular Python code. Python is dynamic, so how can a compiler possibly understand and optimize it? That's exactly what TorchDynamo solves, and in this video, we'll see how TorchDynamo captures Python execution and converts it into something a compiler can optimize. At high level, TorchDynamo sits between your Python program and the compiler. Its job is to capture your program's execution and build an FX graph. But how does it actually capture a regular Python code? The challenge is that Python is highly dynamic. Variables don't have fixed types, control flow depends on runtime values. Even loops may execute a different number of times every run, right? So simply reading the source code isn't enough for a compiler to understand what the program will actually do. Okay, TorchDynamo doesn't read your Python source code like a traditional compiler, right? It never analyzes your .py files directly. Instead, it awaits until your program is actually running. To understand how that works, we first need to know how Python executes your code. Your first Python source is first compiled into a Python bytecode. That bytecode is then executed by CPython interpreter. Every function executes inside something called a Python frame. That's exactly where TorchDynamo enters. Python exposes a hook called PEP523 that lets you replace the default frame evaluator, and TorchDynamo uses this hook to intercept a frame before CPython executes it. It analyzes the frame, rewrites the bytecode, and then when needed, and then lets execution continue. As the rewrite program runs, TorchDynamo is able to observe the tensor operations that are being executed. Each tensor operation that executes is recorded. A linear layer becomes a node. A ReLU then becomes another node. Another linear layer becomes another node. Gradually, TorchDynamo builds an FX graph that represents the computation being performed. Instead of optimizing Python code directly, and then later stages compiler can optimize the graph, that raises another final question. What exactly is an FX graph? That's what we'll cover in the next video. And that's it for this one. If you learned something new, it would be great if you liked and subscribed. And thank you for watching.